Hello viewers, welcome to my YouTube channel Conceptual Analysis of Physics. Today I will discuss the Work Energy Theorem on the basis of NCERT Physics in class 11th. Before start the video, we also know that if the total external force F acting on a body or acting on a particle is the function of the position r, that is F is called f of r. If this happens, then the work done by the force on the particle in a moving from its position then 1 to 2, then we have the following line integral, that is W12, the work done by the particle or the body moving from its position 1 to 2, then we should know that W12 is equal to integration 1 to 2 f dot dr, which represent the work done by the force on the particle moving from its position 1 to 2. And this integral f dot dr is known as the path integral of the force, and it represents the integrated effect of a force F over this space. Okay. Now we calculate by evaluating this integral, which produces the change in kinetic energy of the particle. Let us now calculate the path integral. Thus we have W12 is equal to integration 1 to 2 f dot dr. Then we know f is equal to m dot a from the Newton's second law. Thus a, where a is the acceleration of the particle, and also know that m dot dv by dt, which is represent the acceleration a. We have discussed that this integral produces the change in kinetic energy. So it produces the change in kinetic energy. Now we calculate the path integral. Here f is equal to m dot a, where a is the acceleration of the particle, and also we know that a is equal to dv by dt, which is the instantaneous acceleration of the particle. Thus here we put the value of f, then the integration becomes 2, integration 1 to 2, f is m dot dv by dt into dr. Okay. Now m is the constant, then m into integration 1 to 2 dv by dt into dr by dt into dt. Here we have done it. You can also understand by this concept dt and dt is cancelled out, and the equation becomes this, dv by dt into dr. Okay. This is equals to m into integration 1 to 2 dv by dt into v into dt, because v is the velocity of the particle is equal to dr by dt, where r is the position of the particle and v is called the instantaneous velocity of the particle. Okay, this equation becomes half into m into integration 1 to 2 d dt of v square into dt, because d dt of v square as d dt of v square is equal to d dt of v dot v, and we know the laws of multiplication of the derivative is d dt or d dx of a dot b. This equal to a dot dv by dx plus b dot dA by dx. Okay. By this formula we have calculated, we get v dot dv by dt plus v dot dv by dt, which is equal to 2 into v dot dv by dt. Okay, now here is the equation dv by dt dot v. This equation becomes to be half into d dt of v square, as from this equation we have v dot dv by dt, this is equal to half d dt of v square. From this equation we have get it. This equation we have get this equation. Okay. Now this is equal to half m. Here dt and dt cancel out and we get integration 1 to 2 d of v square half m. Put the integration value and the derivative of the integral becomes to be v2 square minus v1 square. This is W12. This equation is known as the work energy theorem, which is also known that the scalar quantity half mv square, W equal to half mv square, which is called the kinetic energy of the particle, where m is the mass of the particle, which implies that the work done is equal to the difference in the kinetic energies of the particle from position 1 to 2. That is W12 is equal to T2 minus T1, which represent the work done is equal to the difference in the kinetic energy of the particle in position 2 and 1. Here we have three cases. That is, the first case is when T2 is greater than T1. Then W12 is greater than 0. That means the work is done by the force on the particle and the kinetic energy increases. That is, the work is done by the force and the kinetic energy increases. If T2 is less than T1, then W12 is less than 0, which is also known as negative. Then the work is done by the particle against the force. And kinetic energy decreases. And the third one is if T2 equal to T1. When this happens? When V2 is greater than, V2 is equal to V1. When the velocity is constant, then W12 becomes to 0. That is, there is no change. That is, there is no change in kinetic energy. Okay, thank you for watching. If you enjoyed it, then please subscribe my channel and don't forget to like and share with your friends. Thank you.